Hi guys, today we're working on Unit 6, Section 4, where we're going to talk about zeros of polynomials. So a couple things that we need to remember and talk about is the fundamental theorem of algebra, where it states if f of x is a polynomial of degree n, where n is greater than 0, of course, because otherwise it will be just a constant. So then f of x would have at least one solution, one real solution. That's what we're talking about. So it has to be a number greater than 1 on the degree of the polynomial. We talked about factoring a polynomial. We know how to factor, or we should. This rational theorem, root theorem, that's from the end of Section 3, and I figured I would just talk about in Section 4 and actually do some examples, not just a random rational root theorem right here. Okay, so what that is the rational zero. We're going to get p, or all the factors of p, which is the last term of the polynomial, and I'm going to work on an example right here for you. And that all the factors divided by all the factors of the first term, which is q. So it's always p over q, and we divide. So this is what it looks like. I have this polynomial right here, and it's nicely graphed right there. So p is the last term of the polynomial. So in this case, 6. I'm going to list all the factors of 6. So 1 times 6 is 6. Negative 1 times negative 6 is 6. 2 times 3 is 6. Negative 2 times negative 3 is also 6. So these are all the factors that make 6. The other one, I have to find all the factors for q. Q is the first term, so it's that one right there, or the leading coefficient, that number right there in the front. So in this case, it's 1. All the factors of 1 is 1 and negative 1. Now, the possible roots, we're going to use the rational root theorem, which I have to get p and divide by q. P, so let's start here. P is 1 divided by 1, I get 1. And then it's nice when q is 1 because it's just going to be all the factors of p, because I have to do plus or minus 1 divided by plus or minus 1, I get 1. Plus or minus 2 divided by plus or minus 1, I get plus or minus 2. Plus or minus 3 divided by plus or minus 1, I get plus or minus 3, and so on. But sometimes it's not going to be 1. And then you actually have to do that math, and you actually have to simplify the fraction. Sometimes you're going to have the possible roots being a fraction. But we're going to worry about that when we get there. So this is my polynomial. These are the possible roots. Now, when I look at this graph, I can tell that it crosses the x-axis right there at negative 1, negative 2, positive 2, and 3. And notice how negative 1, 2, and 3 are in the list of possible roots. So I have negative 1 is right there, I have a 2, and I have a 3. And they're all possible, and we're going to learn how to test them out next. And where the graph intersects at the x-axis. We already talked about that. So this means there are 3 solutions, aka zeros of the function, or 3 x-intercepts. Also, the degree of this polynomial is 3 because you have, 2 extrema right there, and the end behavior is going in opposite directions. And there are 3 roots, 1, 2, 3. So for page 2, I have the zeros of polynomial functions. Zeros of a polynomial function are the points at which the function intersects the x-axis. We already knew that. The zeros of the function, sometimes you're going to see that as what is the solution? What are the roots? What are the zeros? They can use all those 3 words to ask for the same type of answer, or x-axis, x-intercept, all that. A polynomial function of degree n can have at most n real zeros. So the number at most, Be careful with that, okay? It could be always less than that, but not more than the degree of that polynomial. The factor theorem, we know how to factor. We know how to use the long division. We know how to use synthetic division. Here is what we're going to do. So we have the polynomial, and we have k equals -2. We need to verify that k is the zero of the function, or that k, or -2 in this case, is actually one of the roots. We're going to do that by doing the synthetic division. So you get this -2, you're going to set it up, you get the coefficients of each term, and you set this up right there. You drop the first one right there, then you multiply. 2 times -2, you get -4, and then you add. 1 minus 4 is -3. Multiply, put right there. Add. -11 plus 6 is -5. Multiply, that goes right there. Now you add -10 plus 10 is 0. This 0 in the remainder, that's really good news. The 0 in the remainder means this number right there, that 0 of the function that you just tested, is one of the factors. So you do the synthetic division, you get 0 in the remainder, that means this one is a factor. And we talked about how to go from the 0 of the function to writing a factor back and forth. So if k equals -2, then k plus 2 is a factor. Okay? The sign right there, pay attention to that, is a factor of this polynomial right there, which means -2 is, in fact, a 0 of the function, or one of the roots. I need to write the polynomial as a product. Okay, so after you do the synthetic division, for you to, this result is always 1 degree less than you started off with. So if you started off with a cube, then 1 less degree will be x squared, and then this will be x, and then this is your constant. That's how this came to be from the result of the synthetic division right there. So 2x squared minus 3x minus 5. And then this is the factor that I found out from testing this out. Notice that if you multiply these guys together, that goes back to that polynomial. Okay? So now for the next step, I need to find the remaining factors. Guess what? We need to factor. And I'm just going to flat out do the factoring. Do the diamond, multiply these two to get that number. So -10 and 3. Two numbers that multiply to -3. -10, same two numbers that add up to -3. So 2 times -5 is -10, and 2 minus 5 is -3. Because I started out by multiplying by 2, I need to divide by 2. Simplify the fraction here. That's how I got my x plus 1 as one of the factors. And then this one didn't simplify, didn't divide, so that 2 just goes in the front. So 2x minus 5. So these two are the remaining factors of the polynomial right here. So when I factor this, I get these two factors. And remember, this is also one of the factors. So when I have to determine the remaining factors, these three are the factors of this polynomial right there. If I were to multiply all of those three together, I go back to the polynomial. Ta-da. So state the zeros are the roots or the solution, x-intercepts. So all you have to do is set each factor equal to 0 and solve. So here I got -1 from here. Here I got 5/2 from this factor, and then -2 from this one. And this one was actually given to us right there. And I was positive after testing it out because the remainder right here from the synthetic division showed me that this -2 was actually one of the zeros. I just had to find the other two. So page 3, off we go again. We have to list all possible roots using the rational roots theorem. And I have to do P over Q. That's P, that's Q. Q is 1. So these are all the factors of 8. So 1 times 8 is 8. 2 times 4 is 8. And it's always going to be positive and negative of that number. And the factors of 1 plus or minus 1. Plus or minus 1 divided by 1 is 1. Divided by 1 is 2. Divided by 1 is 4, and so on. So these are all the possible roots of the polynomial using the rational root theorem. Okay. Next one, we need to determine the linear factorization. Oh, guess what? We're going to factor. So, and I can simply factor, and sometimes it works out really nice because I can just factor mentally and be done with it. So I'm going to try to factor mentally. So 2 numbers are multiplied to 8, add up to 6, easy. 2 and 4. 2 times 4 is 8. 2 plus 4 is 6. Done. You should be done right there. Okay, that's how I got the answer. However, the other way that you can do this is by using the possible roots and testing them out. How am I going to test them out? Well, from the previous page right here, I know that that'll be a root if the remainder is 0. Okay, and that's what I'm going to do to all of these, unless I get lucky before getting to the end and I find one of the roots. Okay, that's what happened here. So I'm testing the first one out just because it's the first one there. So 1 goes there. The coefficients of each term goes there. So 1, 6, and 8. And then I do my beautiful synthetic division, bring it down, multiply, goes there. Add. 6 plus 1 is 7. Multiply, goes there, add. Because the remainder here is not 0, that means 1 is not a factor. So then you have to test out the next one. I tested -1 just because I'm going to go down the list. So -1, test it out, multiply, put it right there, add, multiply, put right there, add. So another one that is not a factor. At this point, you're like, I'm just wasting my time here. But well, that's just if you don't want to factor, or sometimes you just can't factor, then you have to do this. Then you have to test them out. Now, check this out. -2. I put the -2 there, and I'm doing my synthetic division like I would. So bring that down. 1 times -2 goes there. Add 4. Multiply goes there. Voila. So that 0 in the remainder, that's good news. So that means the x plus 2 is a factor. Notice how I tested the -2, but because to go from the 0 of the function to the factor, then I have to change the sign. So if this is a factor, that means this is also a factor too, because this is the result of the synthetic division that I did. So this divided by this, I get x plus 4. So notice that I could have done the factoring or the synthetic division by testing each one of those roots out. Either way, you're going to end up with the same answer. Your choice. Now, to find the zeros of the function, you just need to get both factors and set them equal to 0 and solve. So -2 here and -4 there. The next one, we need to show that x minus 2 is a factor of this polynomial, and then finding the remaining factors. So it's giving me the factor. I just need to prove or show that that is actually true. So I'm going to do synthetic division because this is a linear factor. If it was x squared minus 2, I could have not done synthetic division. So synthetic division is always the quickest and fastest way to do the division here. So I get the coefficients of each term right there. So bring that down. That's 1. Multiply. Goes there. Add. 4 and 2 is 6. Times 2. 12. Goes there. Add. 8 times 2. Multiply is 16. Add. 0 in the remaining, on the remainder. That's good news. That means that this guy right here is actually a factor. So we were able to prove that that's true. Now, from the previous examples, I know that if I'm dividing this by this, my result will be 1 less on the exponent. So 1x squared plus 6x plus 8. That's where I got this from. And now I can easily simplify, factor this out mentally. Two numbers that multiply to 8, I have 2 and 4. Same two numbers that add up to 6, easy, 2 and 4. So at this point, I have all three factors that make this polynomial right here. This one that they gave me, and then these two that I found after doing the division and factoring out what I got. So these are the factors of the polynomial. From the factors, I can easily find the roots by setting each factor equal to 0. So usually you would have to put this in order, but it's fine. So plus or minus 2 as the roots, and then -4 right there. One last page. A lot of factoring. So we need to determine the factors and all the zeros or all the solutions. This one, since I'm determining the factors, I'm just going to try to factor. Why not? So two numbers that multiply to -15, -5, and 3. And the same two numbers add up to the one in the middle, add up to -2. So -5 plus 3 is -2. So these are my factors, -5, x minus 5, x plus 3. And then to go from the factors to the zeros, I just need to set them equal to 0 and solve. So -3 came from here, +5 came from here. Easy. Number 2, I have 4 terms. So if you were to follow that flow chart, you know that you're going to have to factor that by grouping. Or if you don't like factoring, the other option is you can follow the rational root theorem like we did here and do synthetic division and test them all out. Your choice. I'm going to do factoring just because it's faster. So factor by grouping, I'm going to group these first two together and then the second two. Find the GCF between those two. I have 9x squared between these two terms. And then I find the GCF between these two, which is -2. Okay, GCF goes right there in the front. Now you're going to divide 9x cubed divided by 9x squared. I get x. 27x squared divided by 9x squared, I get 3. Okay, the next GCF goes right there. And then you're going to do the same thing. -2x divided by -2, I get x. -6 divided by -2, you get 3. Now the two GCFs go together to make a term. That's the term, a factor. And then because this factor matches this factor, that's your factor right there. Okay, so at this point I have my two factors, 9x squared minus 2, x plus 3. Now for me to go from the factors to find the zeros, all you need to do is set them equal to 0 and solve each one of them individually. You know how to solve this, but just please remember, every time you're taking the square root, it's always going to be a plus or minus. Always plus or minus. Make sure you catch that. And then number 3, before I start factoring, I actually need to set it equal to 0 before I can factor. So I move the 10x squared over to the other side, minus 10x squared on both sides. Notice how I have this in order, in standard form. Always look for the GCF first, and the GCF between all of them is x. So divide everybody by x, and that's what I did here. Divide by x, divide by x, divide by x. Then I got my trinomial here. And then from here, I had to factor. Multiply 3 times 3, I got 9. And then same two numbers that add up to -10. So -9 times -1. Because you multiply by 3, you have to divide by 3. simplify the fraction here. That's how I got x minus 3. And then here I can't simplify, so it goes back up. Set each factor equal to 0. This is a factor right there. This is a factor right there. And this is a factor right there. Solve each one of them. Those are your zeros. These are your factors. This is also a factor. That one doesn't disappear. Okay, that's the end of page 4, and that's the end of the notes for section 4.